Hi, my name is Muhammad SAIFUL ARIF AFZAN and my metric number is A20A1560. For the data description, we have prepared the descriptive and summary statistic. The analysis conducted using summary statistic, graphical representation, numerical descriptive measure, statistical analysis using software and theoretical modeling. Most of the variables are ratio scale. Table shows the descriptive variable value for species, price, place, weight, line 1, line 2, line 3, height and weight based on the data population. This variable has been set to organize the data from the Department of Statistics Malaysia. The sizes for the field place where the features captured are Britain 9, Canada 33, France 20, Ireland 8, Malaysia 11, Norway 15, Singapore 18, Turkey 12, USA 25 and Vietnam 8. For the field of weight of fish, the sizes for 0 to 330 grams are 90, 331 to 661 grams are 30, 662 to 992 grams are 27, 993 to 1323 grams are 9, and 1324 to 1655 grams are 3. After calculation made, we know the mean is 4.7987 and the median is 5.
For the next slide, I will talk about sampling data and record categorical data. Before I start, my name is AISYAH NABILAH Binti HAMIZU. My number metric is A20B2318. For sampling data slide, the data that were given to each group is 159, and we have to sampling the data to only 60. And in this table, you can see the data sampling that I have made to only 60 data. For the next slides, I will talk about record categorical data that I have made to 5 different groups. And for the first group, the data from the lowest to 10. And for the second group is 11 to 40. For the third group is 41 to 99. And for the next group is 100 to 299. And for the last group data have 300 to the highest data that we have in the table.
Assalamualaikum warahmatullahi wabarakatuh. My name is AMYRA Binti ZAINUN ARIFIN. My matrix number is A20A1672. So I will present for 3.0 numerical descriptive measures. In this part, there are the measures of central tendency, position and variation. So the table shown is the result that already calculated, and the variables taken is weight in gram, length 1 in centimeter and length 2 in centimeter. So for first one, measures of central tendency, there are mean, median and mode. So mean is sum of data entries divided by the number of entries. So mean for weight is 131.07 gram. For length 1 is 19.555 centimeter. For length 2 is 21.145 centimeter. Next is median. Median is the value that lies in the middle of the data when the data set is ordered. In the sample, there are 60 data entries. So that is even number data entries. That means median is the average of the two middle data entries that after arranged. So median for weight is 112.5 gram. For length 1 is 19.05 centimeter. For length 2 is 21 centimeter. So mode is the data entry that occurs with the greatest frequency. Mode for weight is 300 gram. For length 1 is 19.0 and 20.0 centimeter. For length 2 is 21.0 and 22.0 centimeters. So this shows that length 1 and length 2 is bimodal because there are two mode occurs in the data entries. So next is measures of position. There are first quartile and third quartile. So for first quartile is actually the lower quartile that cuts off 25% of data. So first quartile for weight is 19.75 gram. For length 1 is 13.0275 centimeter, and length 2 is 14.4 centimeter. For third quartile is actually the upper quartile that cuts off lower 75% of data. So third quartile for weight is 128.75 gram. For length 1 is 20 centimeter, and for length 2 is 22 centimeter. Next, the last is measures of variation. There are range, variance, and standard deviation. Range is the difference between the maximum and the minimum data entries in the set. So the formula is maximum minus minimum. So range for weight is 510 gram. For length 1 is 32.5 centimeter, and for length 2 is 34.1 centimeter. Next is variance. The variance is a measure of variability. It is calculated by taking the average of squared deviations from the mean. Variance tells the degree of spread in the data set. The more spread the data, larger the variance is in relation to the mean. So the variance for weight is 14,491 gram for gram squared. For length 1 is 60.73 centimeter squared. For length 2 is 69.575 centimeter squared. Lastly is standard deviation. Standard deviation is derived from variance tells on average how far each value lies from the mean. It is the square root of variance. So the standard deviation for weight is 120.38 gram. For length 1 is 7.793 centimeter. For length 2 is 8.341 centimeter. So that's all from me. Thank you.
Before I start, my name is AISYAH NABILAH Binti HAMIZU. Number matric is A20B2318. For the next slide, I will present about graphical representation. For the first graph is weight category. From the graph, we can see the frequency is highest at the first, and it decreases, and at the middle, it almost hit to the lowest, and increase at the last category. For the second and third graph, it's for length category. From the graph, we can see the frequency is highest at first at 44 frequency, and it dropped to 14 and dropped to 2. That's all from me. I will pass to the next presenter.
Compare with the answer that given by SPSS system, or the answer with the user's manual calculation is matching with the answer of this software. So for 5.2, hypothesis testing. So one sample test of hypothesis. Step 1, state new hypothesis and alternative hypothesis. HO is the average price of the fish is 125. HA, the average of the fish is more than 125. Step 2, state the level of significance. The level of significance is 0.05. Step 3, compute the statistic. So insert the formula and we add the value. Then we get the answer is 0.05561. Step 4, decision rule. Reject HO if HO is bigger than HA. Step 5, making decision and forming a conclusion. Since HO is bigger than HA, so HO is rejected, and conclude that mean of the price of the fishes is more than 125. So the analysis of variant ANOVA. Step 1, state no hypothesis and alternative hypothesis. HO equal to mu1 equal to mu2 and mu3. HA is at least one of the means is different from the other. Step 2, state the level of significance. The level of significance is denoted by alpha. Step 3, compute the statistic. So we have the formula here, and we get the ANOVA from the SPSS system. So step 4, decision rule. Reject HO if F bigger than FA, V1 and V2. So critical region is F 0.05, 4 and 55 equal to 3.15. So step 5, decision. Reject HO since F is bigger than F 0.05, 4 and 55. So therefore there is no significance difference amongst the treatments.
Assalamualaikum. My name is SITI DAMIA Binti JAMALUDIN, and my metric number is 820 and 1976. 5.3 Correlation analysis. This is correlation analysis that we get from the software SPSS and the scatter plot matrix of the variables that are price, weight, and length 1, vertical length. The R values give an indication of the level of correlation between two variables. The prices of fish and the weight of fish is 0.948. The value of R shows that there is a moderate positive correlation between the price and weight of fishes, and the test shows a significant relationship. The correlation between price of fish and the length 1, which is vertical length, is 0.948. This R value shows a moderate positive correlation, and the test also shows a significant relationship between these two variables. And lastly, the R values correlation between the length 1, which is vertical length, and the weight of fish is 0.965. There is strong direct correlation, and the test shows a significant relationship between these two variables. 5.4 Confidence interval. The analysis table shows that the 95% confidence interval for the population mean and significant level is 5%, 100% minus 95%. Therefore, at 95% confidence interval for the head of fish is negative 47.833 for the lower bound and 5.799 for the upper bound. Next, the 5% confidence interval for the diagonal width of fish is 73.329 for the lower bound and 163.067 for the upper bound. And lastly, 5.5 prediction modeling. Y is dependent variable, B0, B1 and B2 is parameters, X1 and X2 is variables. The Y be the price of each fish, X1 be the head of fish in centimeter or cm, and X2 be the diagonal weight of fish in centimeter or cm. For every one unit increase in the head, the price will drop by the rate of 21.017 provided the weight level remains unchanged. For every 1 unit increase in the weight, the price is increased by the rate 118.198 provided the head is unchanged. Since VIF for both independent variables are less than 10, there is no evidence multicollinearity.
For the concluding remark, data agreement, graphical representation, and measure of central tendency, a measure of variation, and a measure of position were used to calculate the data of the values of the descriptive variable for age, sex, BMI, children, smoke, radiation, and charges based on the data. The frequency distribution was used to calculate the number of classes, class, interval, or weight, and class bounds as a first step in organizing the data. The data was organized using relative frequency distribution and cumulative frequency distribution. Two types of graph were employed for the graphical representation, a bar chart and a pie chart.